This video clip will discuss the impacts of pH and hardness on pesticide performance. Viewers should have an adequate understanding of how to determine if they have a pH or hardness issue, as well as how to mitigate these concerns. Applicators count on pesticide products to manage pests effectively. Time well spent on calibrating equipment and selecting the appropriate pesticide usually results in adequate control of pests. A properly managed pest often results in a cost savings to pesticide applicators and the ability to move readily to other pressing tasks. At times, applications result in inadequate pest management using properly calibrated spray equipment at the product rates. This can result in an assumption of 1. Pest resistance, 2. An ineffective pesticide product, or 3. An improperly calibrated sprayer. Frustrated applicators may resort to doubling or tripling the pesticide product rate in an attempt to increase the efficacy of a pesticide product. This is commonly observed when applicators target select weeds with excessive pesticide solution while spot spraying, or adding extra pesticide product to the spray tanks. This often results in increased costs and/or non-target toxicity. Pesticide performance issues are often related to water quality. This is because water is often over 90% of a pesticide spray solution. A small water quality issue can have a significant impact on many common pesticides. To understand water quality, we must understand the hydrological cycle. Precipitation may lead to temporary pools on the soil surface, which may lead to surface runoff. This surface runoff often mixes with soil and organic materials, resulting in an increase in suspended solids causing dirty water. Total suspended solids is often termed turbidity. Turbidity will be covered in a later section. Water may also infiltrate through the soil profile prior to entering groundwater sources. While filtering through the soil profile, water pH and hardness may be altered through contact with various minerals. For example, water infiltration through limestone deposits shown here often lead to alkaline water sources that contain high concentrations of calcium. Acid soils or low pH soils are often associated with areas that receive high levels of precipitation due to the leaching of cationic minerals. In addition, acidic soils can be encountered in arboreal settings when carbon dioxide is released from the breakdown of the thick organic layer often present on many forest floors. pH is the concentration of hydrogen ions in a water solution. This is expressed on a logarithmic scale from 0 to 14, where 7 is neutral. Alkaline solutions are solutions with a pH greater than 7, and acid solutions have a pH less than 7. Weak acid pesticides such as glyphosate and 2,4-D-amine break down quickly through alkaline hydrolysis when the pH is greater than 7, while pesticides such as the sulfonylurea herbicides break down under acid conditions when pH is less than 7. pH is often associated with a high concentration of calcium or magnesium in the water, otherwise termed as the hardness of water. Either pH or hard water can impact your pesticide's efficacy. pH and hardness can be tested using digital meters and/or litmus strips. Litmus strips are inexpensive and can give a coarse idea of pH, while digital meters are more expensive and often need to be recalibrated to maintain accuracy. An applicator may wish to decrease his pH if he finds he's using an alkaline water source when using weak acid pesticides including glyphosate or 2,4-D-amine. Failure to do so may result in poor efficacy depending on how much time the pesticide is in contact with the water solution. pH and hardness can be reduced with the addition of select buffering agents. Dry ammonium sulfate and other non-ionic acidifiers can be useful in reducing water pH and hardness to acceptable levels. Many weak acid pesticides can be significantly stabilized by decreasing the pH solution to approximately 6. Follow all product label directions for determining exactly how much buffering agent to add to your pesticide spray solution. Always consult your pesticide product label to determine compatibility of buffering agents or additional information regarding hardness and pH. Always remember how applicators can optimize the performance of their pesticide products by taking time to assess the pH and hardness of water. By following a few simple steps, an applicator can have peace of mind that they are making effective use of their time.